Hey, hey, hey. Good evening, Ed.
Good evening.
Cheers, everyone.
Happy birthday, Jedi.
Yeah, happy birthday, Dreadeye.
I'm not going to sing for you because that'll just
Apparently,
scare off the whole audience.
I think he won at the bowling, which is good.
Awesome.
Old boy can still do it. Well done, mate. Well done. Right, where are we going tonight, Ed? Where are we
Going to the moon.
The moon. The moon.
Yeah,
I'm so excited.
I just want to caveat this one by saying we're not going to discuss moon landings or whether people have gone to the moon.
Yeah.
People
Okay.
make their own minds up about that. And if they're interested in what we think, then to go back and check out our moon landing episode because we did an entire show about it. And yeah, just to avoid controversy because there's enough of that coming in the next hour or however long we end up talking. So yeah, we're going to the moon. I don't want to make this a whole monologue, but obviously there's a certain amount of talking involved. But let's start off with the simple fact of why are we covering the moon? Everyone knows what it is. It's in the sky. We've all seen it. We set our calendars by it. People all go a bit loopy on the full moon, as you probably know from being a police officer. I remember working in a nightclub. Yeah, at uni. And if it was a summer night and there was a full moon, there was always going to be trouble. And it's just something about it. I mean, it impacts the tides. It has a much, much bigger effect than most of us think.
Can I ask a question about the tides? Right?
Sure.
If the moon affects the tides, why doesn't it affect a pond?
Because of the scale.
But surely it should affect a pond more because a pond's smaller.
Well, it probably does microscopically.
Right, okay.
If you could actually measure the degree of movement in the pond, it's just not. I would imagine it probably moves an infinitesimal amount. But you can see if you look at this slide number 2. I'm not sure if you're on that already.
We're on
yeah,
that
then
right
we got
now.
that. So you can see that's how the moon impacts the tides. And it's one of the things that I didn't realize is that the high tide happens right the way around the planet rather than just one side of it. So I learned something new as well. And it's also in myths and legends. I mean, if you look, humans have been, obviously it's the main thing in the night sky to start with.
Yeah.
And if you think about a world without electricity, the moon would have been very, very important because if you've got no street lights, if you've got no moon, the only light that you've got is starlight, which is obviously not very much, even back in the days before we had so much light pollution. And so a full moon would be really significant because it would mean that you could potentially get stuff done at night. And certainly you'd be less in danger of like being eaten by some sort of saber-toothed tiger or something like that.
Indeed. Right. Let's chat room. Let's just quickly introduce them to anybody else who's lurking. So we've got Julie C, Britt May, Amy. She loves the shirt. She loves the shirt. It's very beige though. It's a bit beige. Anyway,
it's kind of. I just went for something a little bit more subtle.
Yeah, yeah.
And it was actually chosen by a friend of mine. Who has particularly good taste.
It wasn't Johnny and John then.
No, John got me the red shirt.
Right, okay. I think that's the one he hates.
Got me the yellow one too.
Yeah. Britmate says nice lighting, the turkey. No, not a mention of mine though. Not a mention of mine.
You're looking a bit demonic this evening, John.
Well, it's the rabbit hole.
Well, it's Halloween too.
Yeah. We got Soldier in the room. Hello, Soldier. I haven't seen you for ages, mate. Well done. Who else we got? Melted Mushroom, Beats and Types. Bum, 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 bum. And Ray. Ray says it's a hologram. Yeah, okay, Ray. Ray's gone there already. Yeah. We'll find out if it's a hologram or not. I'm sure Ed will have something to say about that. Right, Ed, sorry. werewolves.
No,
Like
don't apologize.
you were absolutely right though, because if it's a full moon, it was always a nightmare when you were a cop because you just knew shit was going to happen. I remember going to a call one night. Some woman had phoned in saying there was a guy lying in our back garden, and we went round and there's this guy stark naked lying in the back garden, right, flat out on the lawn, wide awake, right? And he goes up to him and he goes, "How you doing?" And he's going, "Yeah, all right." That's what you up to? And he goes, "I'm just looking at the moon." And I goes, "Ah?" And he's going, "I'm moonbathing, officer." We're like, "Yeah, okay, right. Either go home or we're gonna have to take you in." And he's going, "I'll just go home then."
Oh, well, at least you didn't turn into a werewolf and start trying to bite your face off.
Fucking knuckles.
Oh, it is, and this is why I don't think that it's a projection to start with, because there are measurable things. I mean, if we forget potentially about humans going to the moon,
Yeah.
the Russians sent a probe to the moon and brought moon rocks back.
Come on. There's a dead Russian on the moon. We know that.
Or
We
the
all know
60s.
that.
Oh, let's not go down that particular rabbit
No,
hole.
we won't.
We'll just end up sucking up an hour and a half talking about whether people went to the moon or not.
Did you know if you're a woman and you've passed menopause, right, you should just follow the moon cycle. And when the full moon comes in, that would be your period. So at that point, because women, even after you've passed menopause, and this is not medical advice, but I am quite knowledgeable. But even after you've passed menopause, you still have fluctuations in your hormones that go with the cycle of the moon. So yeah, just treat that as your period week. And if you were gonna eat carbs, say you were on keto and you were going to eat carbs, that would be the week to do it. Eat it during that week. So this week is your carb week if you're a girly. Okay, right. Sorry about that.
No, it's fine. I mean, you're making a very valid point about the connection between the moon and human fertility, because that's been something that we know for a fact, that humans going back 25,000 years demonstrated an understanding of the moon cycles. And it's, in the same way that you and I have said, oh yeah, people will go a bit crazy when there's a full moon. You don't need technology or anything to be able to figure that shit out. And people back in the day when we were all living in huts or chasing bison or whatever, they're the kind of things that you notice because it's very regular and cyclical. I mean, this is why the first day of the week is Monday. And Monday gets a bit of a bad rap, but we also have the lunar cycle.
Or if you were French, it would be Lunday, which is even more like loon, isn't it?
Absolutely.
But there's a point, actually, and just, I'm sorry to butt in again, but
no, it's fine.
While it's still fresh in my mind, or I'll forget because I am becoming like Joe Biden. But apart from that, 13 months is the ideal period of time for a calendar, because then the moon, every month's 28 days long. Apart, you maybe get one or two at the end that you have to shuffle, but we do that anyway, right? So every month becomes 28 days long, and it follows a moon's cycle completely. Why don't we have a 13-month calendar?
I think that's got something to do with control of people like the church, and then subsequently authority figures who seek to disrupt the normal cycle of things.
Yeah.
Okay. And because, the church has changed dates. The originals, the very first civilization, which sprung up supposedly out of nowhere with loads of knowledge about everything from legal systems through to drainage and toilets and all this kind of stuff, just popped out of nowhere. And that was the Sumerians. And if you believe they just came out of nowhere, then I've got a pier to sell you.
I have a bridge.
Exactly. But the moon is, the thing about the moon is it's a mystery. To start with, it's much bigger relative to the planet Earth than every other moon
it's just
that we know about.
as far as relationship to your parent body goes, it's way bigger than any other planet's moon.
Mm-hmm.
Yeah. I mean, their moon's,
And
what is it, nearly a quarter of the size or something ridiculous? No?
yeah, it's and I mean, if you compare it to Mars, that has 2 moons, but they're minuscule. They're basically just spinning
Potatoes.
rocks.
The potatoes, that's what they are.
Mm-hmm. And it's fair to say that science hasn't explained adequately how the moon formed. We have theories, and those theories have changed over time. I mean, there's George Darwin, 1878, proposed the fission theory, which suggested that the moon was once part of the Earth and spun off due to the sun's tidal forces. The early Earth molten viscous sphere was rotating incredibly fast, completing a rotation in just 5.5 hours. And Darwin theorized that the sun's gravitational pull created a resonance that caused a portion of the Earth to separate, eventually forming the moon.
Yeah, I don't like the. I mean, and I know I'm going off on a slight tangent here, but I really don't like the kind of accepted theory of planet formation. I don't think. I mean, if things would clump together to form planets, how come we've got this huge asteroid belt and then the huge Oort cloud, which are full of nothing but fragments of rock that don't clump together to form planets? You know,
I don't know. The short answer is I don't know.
I mean, it's like when you played snooker or billiards or pool or whatever. When you hit the balls with the other ball, none of the balls all separate. They don't all clump together. You know what I mean?
That's true. But then some certain bodies, for example, the Earth has a spinning metallic core, whereas the Moon, from the samples of rock, I'm not talking here about the Apollo missions, just the Soviet unmanned mission, which brought moon rocks back. And they have the same isotope ratio as they do on Earth. I mean, this is a little bit further in the slides, but it's possible to tell that the Earth and the Moon formed at the same distance from the Sun.
Yeah.
And so the fission theory is essentially these. We're talking about.
Sorry, I'm pointing
theory.
for Amy. There. There. There's a bear. There's a bear there. See, there's a bear.
I mean, if you hit slide 6, that's
Sorry about that.
That's the current. I mean, because we've got various theories: the fission theory, the co-accretion theory, and the intact capture theory. And the co-accretion theory is that after its formation, the Earth attracted a disk of solid particles similar to Saturn's rings. These particles over time coalesced to form the Moon. But the theory struggles to explain the angular momentum of the Earth-Moon system, which would be different if the Moon formed that way. And also the co-accretion theory doesn't adequately address the melting of the magma ocean that would have existed on the early Moon. There's the intact capture theory, which initially was considered the most plausible explanation, which is the theory that the Moon formed far from Earth and was a rogue body captured by Earth's gravity, eventually settling into orbit. However, this theory was discredited when analysis of oxygen isotopes in moon rocks revealed that they originated at the same distance from the Sun as the Earth rocks, indicating a shared origin. Now, I will say that all of this stuff comes from a book that I've been reading. And when I was reading that bit in the book, the conspiracy side of me said, well, yeah, that's assuming that we actually did go to the moon and bring back moon rocks.
And not bits of petrified wood, as they have in Netherlands.
Yeah, which we discussed in our moon landing episode. So there's always rabbit holes, but I don't want to get sidetracked with this, because that rabbit hole aside, the moon itself is already a big rabbit hole.
Yeah,
and possibly it has rabbit holes in it, but we'll come to that later on.
I've seen Moonfall. I know what the moon is.
Have you seen the current?
Have you seen Moonfall?
No, it's fine. Yes, I have. I loved it.
Freaking brilliant movie. So bad, it's great. I loved it. It's just pure. I mean, that is the very epitome of a pure escapist movie. It's just ridiculously flawed, but a cracking good watch.
Mm-hmm.
Yeah, that's what I would say.
It's. I mean, and it's just a cheesy Roland Emmerich disaster
Yeah,
movie, and
yeah, it is.
it's the thing I love about those is that they do spark off questions because he doesn't just make this stuff up, and the ideas presented in the film. I mean, 2012 is something that we're hopefully not, but there's a good chance we could all experience something along those lines in our lifetimes, which is not a very nice thought.
Yeah.
But then, from what I've been hearing from Ben Davidson, we could have a day after tomorrow, and then a 2012, and then God knows, maybe a moonfall. Who knows? But the current accepted theory, as you can see in the slide, is that we have this big impact hypothesis that somehow we have a proto-Earth and a smaller planet that happen to form the same distance from the sun, and they collided, and you end up with this big mess that eventually forms the moon and the Earth.
I don't like
there
it.
Are still no, and there are still issues with the science which suggest that that is not the current scientific consensus is that there was a collision, a formation of debris, and then you essentially have this ejected material forming a disk around the Earth, and it's a bit of a hodgepodge of theories. But as you say, it doesn't explain the oxygen isotope discrepancy. It doesn't explain angular momentum problems.
Whoa, hold on a minute. You just threw something at us there called the oxygen isotope discrepancy, but you haven't explained it.
Okay, moon rocks and Earth rocks have identical oxygen isotope signatures, meaning they formed at the same distance from the sun. And for the giant impact hypothesis to hold, the impacting object would have had to have formed in a near identical orbit to Earth, which it just doesn't seem likely. How would you, if the Earth is forming because this material is accreting, you wouldn't have two things forming and accreting. They would come together eventually because it just doesn't make any sense otherwise.
It's nonsensical. Yeah, I agree. Agree.
And there's also the Earth-Moon angular momentum, which is best illustrated in slide 10. And actually, if you look at slide 9, you can see the oxygen isotope ratios.
Oh, right. I see the oxygen isotope ratio, yeah. So the lunar average is, well, it's slightly different. Not much different, but it's different.
But it's similar enough to know that they must have formed because around the same place from the Earth, because other planets would have wildly different oxygen isotope ratios. And then if you go on to slide 10, that's the other issue with this current theory is angular momentum.
Yeah.
Which the intact capture theory actually supports, but the current big impact theory doesn't. Which, to be honest, I don't really understand it, but it's the effect that the moon has on the spin of the Earth relative to how far away it is. And the moon actually slows the planet down. If we didn't have the moon, Earth would be pretty much unlivable because it would be spinning too fast for any of the necessary things to happen for life to form or to make it a pleasant, water-filled world that we've got now.
So if the Earth was spinning too fast or faster, what would that mean? It would mean that centripetal force would counteract the gravity. Therefore, we'd feel lighter. Yeah.
I don't know.
Well, I'm thinking out loud here.
Yeah.
So, which would then maybe explain why things like dinosaurs could exist then, but couldn't exist now.
Possible.
It's just a theory because they're pretty much certain that you can't go much taller than a giraffe if you've got a heart that pumps blood up to a brain. You know, and when you look at something like a brontosaurus, it's massive compared to a giraffe.
Yeah,
it's just a theory, but maybe the Earth span faster. So either had to spin faster, or the atmosphere had to be a lot denser, or a combination of both.
Closer. sure. I mean, the moon could have been closer as well.
So if the moon was
In fact,
closer,
it
would the
was.
Earth go faster or slower? I
It
don't
would.
know.
I'm not sure. I think it would go faster. But the problem with the moon being closer is that the tides would be absolutely crazy. That when the moon first formed, the tides would have moved a couple of 100 miles inland without too much trouble because it was that close.
Right.
But
Okay.
one of the theories about the start of life on Earth is that the moon actually, the planet actually needed that because of the constant recycling through of minerals and salts and
Yep.
water and all kinds of different things that eventually theoretically clump together and produce life, which there are issues with that theory as well, but that's a whole different rabbit hole.
Yeah.
Um,
Yeah. That is.
and so we basically don't. The simple fact is that we don't know exactly how the moon formed. We know that it's significantly lighter than Earth.
Significantly. Per,
Yeah,
by for the ratio. Yeah.
yeah, and also the impact that because the planet Earth has we have plate tectonics because the planetary shell is cracked like an egg, effectively.
Yeah.
And if you look at the Pacific Ocean, the reason that it's full of water is because it's extremely deep. And if you look at the structure of the planet, it's almost like something hit Earth where the Pacific Ocean is now. And perhaps part of the planet broke off or something and created the moon. Because the other thing that we know about the moon is that it's instead of having a metal core in the same way the Earth does, which we can measure, um, it seems to be composed of material that came from the surface of our planet because of the composition of the rocks and the entire makeup of that, plus the fact that it doesn't seem to have. I mean, it doesn't have any volcanoes. There isn't any tectonic activity. It's
Is
effectively dead.
is there no evidence of previous tectonic or volcanic
No, I mean,
activity?
there's evidence that the surface was once molten and cooled down, but there's no evidence on the moon. There's plenty of craters, but there's no. I mean, if you look at some of the sizes of some of the craters on the moon, indicates very
Cra-
very large
cra-
hits from something.
Craters are a big problem.
The craters are a big problem because they're all the same depth,
Exactly.
which makes
And
no
they're all
sense.
flat bottomed,
Mm-hmm.
and they're
Mm-hmm.
nearly all circular.
Yeah.
So I have my own theory about the craters, but I think it's electrical machining. I don't think it's
Maybe.
impact.
I mean, if the moon is artificial, which is something that we're here to discuss this evening. But if you look, one thing that not many people know, if you go to slide 11,
Mm-hmm.
is that whereas the gravity on Earth is pretty much uniform right the way around the planet,
Yeah.
no matter where you are, whether it's the top of a mountain or whatever. I mean, okay, there's small variations, but the moon actually has massive variations in gravity. Now, on this chart, the blue areas are extremely low. We're talking about Bouguer gravity, MGAP. I don't know what the hell the scale means, but sorry, let me just put that so you don't see the side of my head. So the blue areas are extremely low gravity, and the red areas are extremely high gravity.
Well, the
Now,
red areas are where all the metal is underneath, where the engines are and stuff like
I
that.
was thinking that's where the struts are. I mean, if
Yeah.
you pop open slide 13,
Yeah.
we'll go down that little lunar rabbit hole. And I mean, there are theories that the moon is hollow. I mean,
Yeah.
it rang like a bell
It did.
on
It did.
a number of occasions. One of the things that I find fascinating is the numerical relationships. For example, the moon is exactly 400 times smaller than the sun,
Yeah.
but is exactly 400 times closer to the Earth, which is why when you look up into the sky, the sun and the moon actually look like they're the same size.
Yeah.
Now, we're also, I mean, this is coming in a minute with the megalithic yard, but the moon's diameter fits into the Earth's diameter 3.66 times.
Right.
And the old a Sumerian circle had 366 degrees because you can break that up perfectly into minutes and seconds and everything else, whereas we have a 360-degree circle. And the Sumerians also had base 6 math. We have base 10, where everything's done in tens. The Sumerians use 6s instead. And 6 is actually, particularly for things like geometry and stuff, 6 is a much better number to use.
Did they have
but it's
6 fingers or something that would lean them towards 6?
Well, no, because there's also base 10. The thing is that you use base 6 for some things and base 10 for other things. It's the same as, I mean, we do the same thing.
Yeah, we use hex, don't we?
Sure. But
which
also
is what, base 12? Yeah.
Yeah. But also there's binary, which is base 2.
Yeah.
But for time, we measure time in base 6 because an hour has 60 minutes and there's 60 seconds in a minute. And that's all related to the fact of the Earth going round on its own axis around the sun. There's also circumference relationship. So the moon's circumference is 10,920.8 kilometers. And that number is highlighted because it aligns with the number of Earth diameters in the sun's diameter, which is 109.2. And the number of sun diameters between the Earth and the sun at its aphelion, which is 109.267. Yeah, there you go. That slide, well done.
So I should still be on this slide, yeah. 14, yeah. Okay, cool.
Yeah, so there's, when you actually stop and think about it, the fact of what are the chances? What is the mathematical probability that this happened by accident? But let's keep going because the stats are fascinating.
Like you said, though, the moon was closer, and it is getting further away because it's drifting away at what is it, 2 centimeters a year or something? Or
yeah, but what that means is that if we assume that the authors in the book call it an unknown creative agency, UCA. So let's just say for the sake of argument that the moon was created by this UCA.
Right.
It was done in such a way that the point in our evolution at which we would be able to measure these things and understand these things happens to coincide with the period when the moon is in the exact position it is. So whoever did this,
but that would mean they would know our development path in advance.
Well, there's still issues.
Jesus, but do you know what this means?
Well, yeah.
Time travelers came back and built the moon. This is like a self-fulfilling prophecy, right? So time travelers had to come back to build the moon to kickstart life, so they could then come back and build the moon to kickstart. I mean, that's it's some kind of time traveling fallacy loop gone mental, is it not?
It does seem a bit that way, but it gets more crazy because the ones that I've mentioned aren't just the only ones, and we also haven't gone to the megalithic yard yet, which we're coming to, because somehow a system of measurement was developed around this whole Earth, Moon, Sun relationship, which the ancients were using and which shows up in all sorts of different, megalithic places. And the Sumerians used it as well because there's relationships in that. And there's actually relationships between the pint, for example, and also the meter, because the Sumerians used measurement. I can't remember off the top of my head what it was called, but it was within 99.5% of a meter. But we've got, so there are also rotational and orbital characteristics, which are really interesting. Now, the moon rotates at a rate of 400 kilometers per day. There's that number again, which equates to 1% of the Earth's rotational speed.
Okay.
And there's, again, we've got the 400 and also the 1%. So the moon travels around the Earth at a rate of approximately 1 kilometer per second. This speed fluctuates slightly throughout the moon's orbit, but remains close to 1 kilometer per second. Again, the use of a kilometer is potentially problematic. The moon completes 366 orbits of the Earth in 10,000 Earth days. The repetition of the number 366, which is it's called the Earth pin. Each planet has its own pin, effectively. So then we get onto megalithic geometry relationships. So the megalithic yard, defined as 82.96656 centimeters, neatly divides the polar circumference of the Earth into 366 units when using a 366-degree circle. The moon has 100 megalithic yards per second of arc based on its circumference and megalithic geometry. And the sun has 40,000, there's the 400, like 400 again, megalithic yards per second of arc based on its circumference and megalithic geometry. So essentially what we're saying is that there are these relationships, these mathematical relationships and these numbers which keep coming up, which just seem unlikely to be accidental, just the formation of planet. I mean, yes, of course, it's possible.
Yeah. Okay.
Go on.
What's the right? Yeah, I don't even know where to start. Like, who did it? Why? How? When? What for? You know, I mean, it's just every question under the sun.
Sure.
Does the mega?
But then
If you're going on about the
megalithic yard.
Yeah, but if you're going on about the megalithic yard, then does that not take some of its findings from the sizes of the moon and that?
It does partially, but they wouldn't. I mean, how would people that far back, assuming that what archaeologists tell us about what people were like back then and what the state of human development was, how could they possibly know the circumference of the Earth in order to be able to divide it up into 366 nice little pieces, which then inform everything else that they're doing?
But how did they know then to divide up the Earth such that they all seem to have built pyramids on, equidistant from certain areas and from each other? And so, I mean, one then comes back to there must have been a more advanced earlier civilization that got knocked on its ass.
Yeah, I mean, I think it's undeniable at this point, personally. Yeah. I mean, everything that I've seen, all the research that I've done, suggest it's the only thing. It's what Sherlock Holmes always says. Once you've eliminated the improbable, whatever remains, however impossible. Oh, sorry. Once you've eliminated the impossible, whatever remains, however improbable, must be the truth.
Yeah.
And that's kind of, but that's also kind of where you get to with the moon. Because if we look at some of the stuff about the moon's interior, to start with, it's either hollow, has a very small core, which stems from the ringing like a bell effect observed when objects like the Apollo 13 booster impacted the lunar surface. The analysis of the moon's motion and gravitational field led some scientists, such as Dr. Gordon MacDonald and Dr. Sean C. Solomon, to consider the possibility of a hollow moon. This notion, however, is countered by data from the Lunar Prospector magnetometer, suggesting a small metallic core approximately 680 kilometers across. Now, a small metallic core, that doesn't exclude the possibility that it's a small artificial core or some sort of alien AI computer, or I don't know.
A probability engine.
But it's the point is that when humans fired things into the moon and measured, they put seismometers there to measure it.
Yeah.
And when they did that, they got results that nobody to this day has been able to adequately explain, because the Earth doesn't ring like a bell when you fire something into it. And the only reason it would ring like a bell is if there was either it was hollow or there's significant gaps like Swiss cheese or
like
something like that, but
like
a
huge
lot more.
caverns and stuff. But they
Mhm.
would need to be huge and extensive.
Yeah, certainly for it to register on a seismometer.
Or if it was
Um,
basically a metal shell underneath all that regolith, and that's why the craters are all the same depth.
mhm.
I
I
don't
mean,
know.
the science says, oh, there's no proof that the moon's hollow, but then there's no proof that it isn't hollow either.
Yeah.
And actually, on balance, the best evidence that we've got suggests that there are at the very least large caverns in the moon that, sorry, my mic, hang on. Yeah, that suggests that there's large caverns, but they, as you say, they'd have to be bloody enormous.
Yeah. Yeah, they would.
And they would also have to have some surrounding structure, because how do they stay hollow? Don't you, you'd get cave-ins and all this kind of thing. So
Well,
the outside shell of the moon must be
yeah.
completely rigid, or as you said earlier, maybe it's metal just covered in dirt or something.
Well, I mean, let's face it, the moon doesn't have any atmosphere. So any dirt that falls on it isn't getting burnt up. It's just landing on the moon. And that's going to be what that regolith is. I mean, it's like if you leave a house without dusting it, eventually your skin cells will build up to the point where there's a substantial layer of dirt lying on everything.
Mhm.
And that's
Sure.
probably what's happened to the moon to a degree. Yeah.
Well, it also, I mean, if you look at the asteroid, if you look at the craters on the
Mm-hmm.
moon, those are the results of impacts. Now, we don't
Well,
see these
we don't
giant
know that they
boulders.
are because they've got there's craters there that obfuscate that as a theory and actually confound it, because there are craters where there are craters on the rim of other craters, and it
Mhm.
just doesn't work. And all the
But how
craters
would,
seem to be round, and this is why I think you know. I mean, it could have been something like Mars or Venus or whatever came past, and there was a massive electrical discharge that basically machined the craters into the moon. Because I don't think there's anywhere near as many craters on the dark side, is there?
I'm not sure. I think the dark side is actually more pockmarked.
Oh, is it? I thought it was.
Yeah, let me see if I can pull an image up and stick it into the slide deck.
I thought one side was a lot flatter than the other.
Let me just. I'm going to stick a slide in at the end. Yeah, if you go to slide 20.
Yeah. But that's the.
I mean, that's.
Wow, it's hard to tell, isn't it?
Mhm.
That's a big one there.
Um, and it's also the fact of because the dark side of the moon is obviously the side that's always facing away from the Earth. Now,
Yeah.
if you're going to be a super intelligent alien civilization or something, and you wanted to set up a monitoring station so you can broadcast your Earth soap opera to the rest of the galaxy, which is what I sometimes think is happening, that it's just the whole planet is just a big Truman show. we just we're just the laughing stock of the whole galaxy.
There's big problems though, isn't there, with the distance? It's. I mean, I've been doing a lot of research recently into UFOs and UAPs and all that nonsense, and I've always looked at
It's
space,
not nonsense.
and I've always looked at. I've always been interested in space anyway, and I've been doing a lot of research, and it's the distances that are the issue. The distances are immense, and this is why I keep banging on about Elon Musk is completely wrong, because we aren't going anywhere with rocket technology. We're going nowhere. We'll be lucky to even get to Jupiter, or anywhere in the solar system with rocket technology. It's a waste of time. We need to devote our our resources and our time on basically breaking the laws of physics. Because if we can't break the laws of physics, we're not going to conquer the galaxy. We're not even going to conquer the solar system. That's just
that's
my
very
view.
true. Well, no, it's absolutely founded in lots of logic and sense. I mean, there's an argument that some of these UAPs that we see in the sky, if they do come from elsewhere, that there's a good chance that there's some sort of artificial intelligence on board, simply because of the distances involved and the vagaries of interstellar radiation. And because once you get off the nice protected surface of the planet, if you're up in space and you're not protected by a planetary geomagnetic field, the amount of radiation that you'd be subjected to, even this distance from the sun, would not be healthy.
And then once you get outside the solar system and you're in cosmic space, the amount of cosmic rays are going to be immense.
Mm-hmm. Absolutely.
Do you know how long it would take to go to Alpha Centauri with current technology?
Longer than we've got alive.
I would say so. You know how long it would actually... Alpha Centauri is only 4.5 light years away, okay? That's our nearest star, other than the sun, right? So to get there with current technology would take us 800,000 years. Now, just think about that. That's not a generational ship thing. That's like evolution. I mean, you could leave here as humans and end up there as shrimp. You know.
Yeah, I mean, if you look just at the Voyager probes.
Yeah.
I mean, they're traveling really quickly now, and they've used all the gravity assist and stuff getting out of the solar system. They've been going for like 40, I think it's 40 years, 45 years, and they're literally just getting out to the edge of the outside of the solar system.
Yeah, yeah.
Which kind of puts it into a more human sort of context, because even I mean, we can't even think about 1,000 years, let alone 100,000 years.
Yeah, I know. I mean, do you think about it? I mean, Voyager's been going, well, nearly all your life, if you think about it that way, right? Voyager was launched in what, 74?
I think, yeah, it's
71.
Yeah.
Anyway, I just off it was the early 70s anyway. So Voyager was launched in the 70s. So are people alive right now who were born while Voyager was launched, right? So their entire lifetime, Voyager has still to leave the solar system.
Absolutely.
That's crazy.
And it's mind-blowing. But what's even more mind-blowing is the megalithic yard, which it was discovered by Alexander Thom, but it wasn't independently conceived by Neolithic people, but given to them as part of a larger message, because they did get it from somewhere. Even the Sumerians have got a very clear story about Enki and Enlil, Anunnaki, that we kind of, I mean, this is we've talked about it loads.
Yeah, we have.
The connection to the moon's dimensions mean, as you said earlier, there must have been people that were watching the moon and using that to determine seasons and planting and when they can touch their wives safely and all this kind of thing. But the fact that it's a precise integer for the moon's circumference when applying a 366-degree base geometry, how would megalithic people know what the moon's circumference was? Because you can work it out. Well, you can work it out if you know the distance.
Yeah. How does the Dogon know about Cyrus B?
Precisely. But why would this megalithic? Why would this unknown creative agency give proto-humans this perfect measurement system? Because it is. You can use it to measure time. You can use it to measure distance. You can use it for geometry. You can work out angles and circles and distances and all kinds of cool stuff.
Mm-hmm.
But it's all based on the circumference of the moon, not the circumference of the Earth. So, I mean, the authors of the book that I was reading, which I'll show you in a minute, that basically suggests that this UCA, the Unknown Creative Agency, was using the moon as a message. And the whole message being that there's life out there because it just created you guys, kind of thing. That's a rather flippant way of putting it.
So are we saying this Unknown Creative Agency is supernatural?
Well,
are we talking about God?
We could be. The nice thing about calling it an Unknown Creative Agency allows for, well, it's a great, I mean, it is a great catch-all term.
Yeah, Harold says UCA is hardly a catchy name.
Oh, no, fair enough, but it's a good way of describing it.
Yeah.
And keeping things rational and logical at the same time, because we're here to do rabbit holes, but at the same time, yes, we can go off into idle speculative fancies, but we'll kind of always point out that that's what it is, and we're here to. This is why the moon is a great example.
Yeah, it's a great example because there are so many coincidences about one, its size, its distance, its effect it has on the Earth, the requirement to stimulate life if we accept that it evolved from the oceans. But then this Unknown Creative Agency is what? Because we've already talked about the distances being so vast that no normal technology that we are aware of could get us across them in any kind of sensible time span.
Yeah, but if you've got the ability to break off a chunk of a planet and turn it into a moon and somehow engineer it so that that moon is the perfect size to allow life to flourish on the planet, and actually maintain it, because the moon causes the seasons. And actually, one of the interesting passages in the book, which I'm not going to bore everyone with just reading it out, but if you look in the book of Genesis, when God creates everything, you can actually attribute various aspects of the moon's creation to what's attributed to God in terms of, oh God, I'd have to look it up because I can't remember, but it does, like creating the heavens and the earth and the water and splitting the water off, and then creating the seasons. And those are all things that the moon does. Without the moon, we wouldn't have seasons, because the seasons depend on the tilt of the planet on its axis, which is caused by the moon.
Oh, is it? Because, I mean, the other planets have all got a tilt.
Do they?
Yeah.
I think they do.
Oh, come on. Come now, Ed. Come. come. Right, hold on. I'll need to look this up, but yeah, I'm pretty sure. Right, let's have a look. Planet tilt and Venus is going to be the odd one out. I'm going to start with Venus, because Venus is the odd one out, because that's the only one that is in a retrograde, spins in a retrograde direction. Axial tilt on what? Earth. Where's the Earth? Why have I got Earth? I wanted Venus. Solar system bodies, axial. Here we go. Axial tilt. Mercury 0.03. Okay, very little. Venus 2.64. Earth 23.44. Mars 25.19, and yet we know that Mars has teeny tiny moons, right? Jupiter.
It also has no atmosphere.
Well, it does. Its atmosphere is 90% carbon dioxide, but it's very thin.
Sure. I mean, there are theories that Mars was once a much more Earth-like planet.
Yeah, but if Mars hasn't got an atmosphere, how does that fucking helicopter fly around with rotor blades? Got you there.
Maybe it's
right.
maybe it does have some atmosphere.
Yes, it does. It's got a thin atmosphere because it has winds which rip around at what horrendous speeds. You think a hurricane here's bad? Try wait until you're on Mars and a 400, 500 mile an hour wind is churning the sand past you. That'll take the skin off your nose. Anyway,
Well, yeah.
Jupiter.
You're cursing Elon Musk for his idea to get you on the stick.
Look, if you go to Mars, right, you might as well just go and live in a cave here because that's what you're going to do on Mars. You're going to have to live in a cave because you can't stay up top because the solar radiation, any solar flare, and cosmic radiation will do you in jig time. So you're going to have to dig a tunnel or a cave or find a lava tube, and you're going to have to start living down there, right? So forget building cities on the surface of Mars. Everything would need to be underground. That's why Mars is a crap location. Really crap. If you go to like Titan, which is my favourite, Titan's got a thick atmosphere. It's nearly all nitrogen, right? But that mitigates the problem with solar and cosmic radiation. You're right slap bang next to Saturn, which is a 26.73 degree tilt, right? And that gives you the benefits of a huge magnetic field and a really readily available source of water. Anyway, Uranus 82.23 degree tilt, Neptune 28.32, and Pluto 57.47. They've all got a tilt, mate. They've all got a tilt.
Thank you. Anyway, the point being that the moon is still different, even relative to all the other planets, like we were saying at the beginning. It's much too big.
Yes, it is.
And the simple fact is we don't know how it came into existence. But if we suspend disbelief for a moment and assume that whoever this creator of the moon was, intended it as a message, what evidence have we got that might explain that? Let me just run through. There's 3 points. To start with, the big one that we've already mentioned, which is the size. And its perfect visual alignment during total eclipses. While seemingly coincidental, it's described as the most unlikely coincidence imaginable, which it is. I mean, what are the possibilities that the moon would form and it would, when our civilization was kind of up and coming and the period that humans were relatively able to understand these things, i.e. we weren't like Cro-Magnon man or anything like that, happens to be when the moon has reached the point of traveling, because it is traveling slowly away from the Earth, but it's got to the point where it covers the sun precisely, which, I mean, that doesn't happen anywhere else in the solar system.
No,
frankly. And if you were able to create something like the moon, engineering it so that this would happen would be a pretty good way of getting people interested, at least. We've also got, where are we? Sorry, I'm just a bit confused in my notes. Yes, basically, the whole point is that it's been tailored for our understanding now.
Yeah.
And that approximately 6,000 years ago, where we've got this introduction of the megalithic system, which is the Sumerians. Mm-hmm. And the Sumerians say they got it from some beings called the Watchers, which effectively the Anunnaki, I think. But I think, although the Anunnaki, they're basically gods of the Sumerians, and they're more of an origin story, whereas the Watchers, I think, seemed like actual beings of some description. Now, whether they're survivors of a pre-flood civilization, which is what I happen to think, because when you look at different origin stories, because you've got the Quetzalcoatl in South America.
Yeah.
which again is this god that comes from the sea and teaches all of the primitive people how to live like civilized humans, and there's a lot of
How'd that work out?
similarities. Not very well.
No.
I don't know. I don't know if we've been repeating the same cycle for 12,000 years. It's starting to feel a bit like Groundhog Day. That,
Yeah, I think it is, mate. I think it is.
Yeah, you have this cataclysm and it destroys everything, and then the survivors rebuild, and it takes them about 6,000 years.
And then along comes
to get
another
anywhere.
cataclysm and knocks you out again. Yeah.
Well, yeah, and then it takes them another 6,000 years, and it's just Groundhog Day, and then you do it all over again.
Mm-hmm.
So, I mean, that's basically the end of the moon stuff. We can try and answer some questions or have a bit more of a discussion about it. But I personally think it's fascinating.
About the evolution of human intelligence. Where did that come from?
Oh, that one was, that I just chucked that in there because it's this notion that if this unknown creative agency created the moon, then maybe the explanation for where humans evolved from could be answered from, because it's not just humans, but all of life on Earth. The current idea is that we evolved from this primordial soup in some prehistoric version of the Earth.
Yeah,
there was no life, and there was this primordial soup of different chemicals which came together to form amino acids. Yeah. And the amino acids gradually created all life on Earth. Effectively, that's the current theory. The problem is that nobody's ever been able to create anything well, exactly. They've tried all different combinations of primordial soup, as they call it, with all of the different elements necessary, and they've tried applying electricity, because there are some theories that it was a spark of lightning that created the Earth, created life. But there's no actual evidence that that's even possible. So what if this unknown creative agency also seeded life on the planet in addition to creating the moon, and that somehow knew that it would take roughly a certain amount of time for something intelligent to come out of whatever material they seeded on the planet, and that somehow the moon would essentially be in the position that it's in by the time that the most intelligent creatures evolved on that planet to understand the significance of it. Mm-hmm. That, in a nutshell, is this whole moon as a message theory, which boggles the brain. I mean, I guess
it does.
I don't know. It's any alien intelligence that is capable of doing something like that, it might as well be God, frankly.
Or a time traveler.
Or a time traveler. I mean, like you said, maybe it is that crazy. But we're talking, maybe future humans get to the point where they realize, shit, we've got to build a time machine because we've just found a message in some place that, because with our technology, we're capable of understanding certain things. Now, if the moon was a message and it was created such that it was in the right position now for us to understand it, mm-hmm. If in 1,000 years, for example, assuming we don't kill ourselves in the meantime, but surely that would follow on through time, where at some point in the future, maybe there's a message that's understandable by those future humans, which tells them that they've got to get their skates on, build a time machine, go back and create the moon and start the whole thing off, because it's just this giant bloody circle. I don't know. I mean, we're discussing the possibility that something created the moon. So if we're going to do that, we can go wherever the hell we like.
Well, yeah, I know. I mean, the moon's an oddball thing. It really is, because, as you said, one, it's too light for its size. It's not dense enough for its size. It's made of the similar materials to Earth, but it's not the same. All the craters are round, which means every asteroid had its square on.
Yeah, that doesn't work.
When you said that earlier, I thought, no, he's absolutely right, because for it to be asteroid impacts, every single asteroid would have had to have been hitting it at a 90-degree angle to form a perfect circle.
Mm-hmm.
Because otherwise you would have rugby balls and all sorts of other different shapes.
Yeah.
In fact, you probably get very few perfect circles.
Exactly. Yeah. You ever been to Meteor Crater in Arizona? That's pretty much a perfect circle as well.
Mm-hmm.
Electrical machining. Grand Canyon, electrical machining. Massive so seriously, massive electrical discharge, right? Tears all that material out.
It's possible. I mean, there's the
Valley Marinaris.
Val Marinaris.
Yeah.
Mm-hmm. And that actually, the Grand Canyon doesn't look quite so much like that, probably because
it does.
Weathering. Well, I suppose it does from space, but with Mars, with the Val Marinaris on Mars, it's much more apparent that looks like some sort of electrical discharge.
Yeah, because when you look at the Grand Canyon and think, oh, the Colorado River did that. Well, did it really? Did it really do all those little electrical type filigrees that come out from the all this little tiny tributaries that aren't water tributaries? They're just canyons and I don't think so.
That's
I think water filled it up after it happened.
Think about it.
Yeah.
We've got enough to worry about with giant electrical bolts lashing out at us from the sun. Jesus.
Yeah. I mean, well, have you looked into the electric universe?
Yes, not in a huge amount of detail.
Yeah,
I'm just thinking we should write to Roland Emmerich and suggest that as an idea for another disaster movie.
Because I mean, one of the theories is that. And see, this is a problem with comets, and it's quite topical, I think, because there's a comet on the go right now, isn't there? And comets have tails, and the theory was always that comets were like loose collections of ice and stuff that was sublimating as they got heated up by this as they got closer to the sun, so their tail come out, and the solar wind.
That's what it says in the movie Deep Impact, anyway.
Yeah, but hold on a minute. How are these comets, right, heating up when they are out past the fucking orbit of Jupiter?
Yeah, but surely you'd only see the tail.
No, you see the tail. You see the tail from quite a distance out.
Okay.
I mean, well beyond our orbit, you can see the tail because you can see the tail coming in. So also
the tail is created.
So here's the theory. Here's the theory, right? The comet, and remember, we landed on a comet and got a fucking shock because it turned out to be stone. It was rock, right? It wasn't a loose collection of fucking, it wasn't a dirty snowball. It was rock. And when the thing hit it, it bounced off it because it wasn't snow. It wasn't ice. It bounced off it and fucked itself. And things that were predicted by Wal Thornhill, who's now dead, but Wal Thornhill predicted as that impactor got near the comet, there would be an electrical flash because the electric universe theory is that the comet has the opposite charge from the solar system. So when it comes in, it starts to ground itself. And that's what produces the tail. It's electrical machining, i.e. spinning off some of the debris from the comet. It's not sublimation, it's electrical discharge. It's an electrical discharge corona. Sense. Yeah. It does make sense.
I think, and I mean, I think the electric universe is maybe a good idea for a future episode because I haven't really done that much research into it.
Yeah.
And so it would be good from a kind of novice's point of view to see what the hell is this theory, because the more and more that I learn about how the universe works and how we work on the planet, I think everything's just electricity. It flows through all of us. It's in the planet. And we think it's sort of separated off into cables because that's a I guess that's one form of it, but it's everywhere. I mean, I think
See, this is the thing about electricity, because we don't even know how electricity works. That's the problem, because everybody thinks of electricity as like water flowing through a pipe, but that's not how electricity works.
What we do in the West, because we've got it coming in sockets. If you've lived in places without reliable electricity, then you don't think of it like that. But your point is still valid, though, because we don't understand what it is. We're just making a flippant remark.
Yeah, and I mean, the thing that really screws with your mind is, the two that screw with my mind is wireless charging, right? There's no connection. There's no physical connection between your phone, your phone's battery, and it's an induced field, obviously. But how does that work? How does that recharge a battery? And then there's batteries themselves, because there's no difference in weight between a charged and a discharged battery. So how do you get? It doesn't get more electrons, so you don't use electrons up. So how does electricity? And I'm still waiting for someone to actually tell me how, or to explain to me how electricity works, because no point in asking an electrician, because they're great on practical and how to use electricity, but no idea how it actually works.
I think that's in some cases you don't need to know, but I think it's important to know. And the fact that we don't, but it's the same as the moon. But it speaks to a more fundamental point about humans in the 21st century, that we think we know a lot, but we actually know nothing, or very little, or a lot less than we think we do. And I don't know, this whole idea that it's like with the science, the arrogance of some scientists, where they think they just have the answers, and they just don't. They're not open to new answers. They just censor anyone that doesn't agree with them.
So,
yeah.
So Dread says free electron travel, but the electrons don't travel, and nothing leaves the cable. Nothing goes from the cable into the appliance, and again, you get back to it's like, and I keep banging on about this, but how can they even charge you for your electricity when there isn't a direct connection between the power station and your house? There isn't. Because if you think about it, they generate power, or they manifest it or whatever, but power is manifested at a power station. It's then put through a transformer where the electricity never touches itself, you know what I mean? Because you have a copper winding on one side and a copper winding on the other with different levels of coils, which either steps up or steps down the current, right? So they step up the voltage and drop the current so they can transfer at massive distances. That's why power lines are like at 65,000 volts, but really low ampage, right? So they don't lose the power when they're transferring it. Then it comes to a substation where it goes through another transformer. And again, these transformers aren't connected internally. The power will come in at 65,000 volts and come out at 240, right? But they're not connected. There's no direct connection. And if you go
some sort of wireless transfer.
Well, no, it's the magnetic field. It's a transformer works with basically a metal bar magnet with copper wire around it, right? And if you put power through one end, it will induce power on the other. And if you have different sizes of windings, you can make the power go up or down, right? Now, there's a certain degree of loss, right? But see, this is the problem. People don't know what force means. People don't know what field means because nobody ever defines it. That's the problem. I mean, they talk about lines of magnetic force, but there are no lines of magnetic force when you actually think about it, because the whole thing works as an entirety. It's just very confusing. And then you can stand beside a transformer station and steal power. If you have a winding or whatever and go close enough to a power station, you can steal power. You can stick a fluorescent tube under a power line, put one end in the ground and the thing will light up.
Mm-hmm.
So that's mental, because that's not magnetism, because, you know, the fluorescent tube's not magnetic. It's wild.
But it just means that there's stuff happening that we can't see.
Yeah.
Obviously, you can detect it because you can light up a light bulb. But I agree, and I mean, don't ask me for an explanation about what electricity does. I use it every day, but
yeah, no,
I use a computer every day, and I don't care how they work either.
Well, yeah, I know. I mean, but if you think about it, electricity is a fundamental part of life, because everything in your body works through electricity, and your cells, your heart, your brain, everything is done with electricity. Your nerve impulses and changes, you know, the commands that you issue for stuff to move. It's pretty crazy when you think about it.
Absolutely. Yeah. And I mean, particularly when you think of how dependent we are on it, and how most people just see it as a normal thing. You need to charge your phone or turn the lights on or make a cup of tea, and it's just there.
Yes, I was at the Coop today, and Coop is a Scottish word for tip, or council refuse recycling centre, or whatever they want to call it these days. And there's a wee guy there who's a bit of a conspiracist, which is not a bad thing in my view. And I asked them a couple of questions today, and one of them was, what did he think about people that take out their electricity meter? And he had the same view as I have. He hasn't ever met anyone that's managed to do it and not end up in the jail. And I said, yeah. He says, you know, they talk about it. He says, but you can't do it. And I goes, well, the only way that you could get around it, in my view, right? And I'm not suggesting anyone does this, but energy usage is monitored at point of use, right? So if you bypass the meter, right, i.e., let's just say that you don't pay your electricity bill and they come and take your meter away, because that's what they'll do, right? Eventually they'll come and take your meter away. So you don't have an electricity meter, so you don't have electricity in your house. But you do, because the infrastructure's still there, right? Now, if you connect, and you're not allowed to, it's illegal, right? But if you connect those electricity tails straight into your fuse box, right, you will have electric power. And they can't tell that you're using power, because they don't monitor it at the power station, because then they need a meter there for every house. They'd need every cable. They'd need to be able to tell who was using power. So they can't actually tell if you're using power or not unless you've got an actual meter. And it's the same for gas, if you think about it, you know?
Yeah. The problem is that to do that yourself, you'd probably die.
No, you could do it. If you know what you're doing, you could do it, right? Apart from that, though, and I'm not suggesting anyone should do it, right? Apart from that, they would never have any reason to come to your house, because you've not got a meter to read. You know what I mean? So there's never any reason to come to your house unless somebody grasses you in.
Yeah, but John, if it was so easy to do, nobody would be paying for electricity.
Oh, it is easy to do, mate. It's just nobody breaks the law. That's the difference. I think there's a lot of things that are very easy to do, but nobody does. You know, very few people do it. I mean, it's very easy not to tax your car and not to insure it and drive around with it, but not that many people do it.
Yeah, but you can. I mean, it's a lot more easy to get caught for not being taxed and insured and MOT these days.
Yeah, yes, with ANPR and all that, which again I think is a breach of the Data Protection Act, because DVLA is selling your registration data to private companies.
Yeah, good luck making that stand up in court.
But they are, aren't they? They're selling your registration data to private companies. How can that be legal?
Well, it's the government. They made it legal.
I know, it's crazy, isn't it?
Well, they break their own laws at will whenever the hell they want
to. Yeah, they do, absolutely. But yeah, so electricity is a weird one, and the whole battery thing is bizarre. You know, especially wireless charging a battery, which is what you do when you put your phone on a wireless charger.
I mean, Nikola Tesla always said that stuff like that was possible.
Mm-hmm. He did.
So
yeah, he did. Yeah. But I mean, Tesla wanted to manifest energy from thin air, effectively, didn't he? Because there's a massive energy potential difference between like a 1 meter up, 2 meters up, 3 meters. Every meter, the voltage goes up. So there is a massive potential difference. The higher you go, that's why he built that tower.
Wardenclyffe.
Yeah.
It also makes you, I mean, it does make you wonder what was in all of his confiscated notes that were taken away when he died. And
Trump's uncle. Wasn't it? It was, wasn't it?
Was it?
Yeah. Was it? It was Donald Trump's uncle, wasn't it?
You're joking.
Oh, fuck. Come on. Come on. Now, Ed. Would I joke about such a thing? Hold on.
Well, yeah.
No. Right. What was the Tesla?
I mean, you're probably right, but that's an absolutely crazy coincidence if you are.
Trump's uncle? Let me see. What was it? Right. So Nikola Tesla's missing files. 2 days after Nikola Tesla died destitute in the New York City hotel, the FBI called MIT professor and esteemed electrical engineer John G. Trump to determine if any of the belongings in the investor's estate, which included a purported weapon of mass destruction that Tesla called the death ray, would be dangerous if they fell into enemy hands. After a 3-day investigation, Trump, in fact, the late uncle of Donald J. Trump, determined there was no risk. Yeah, so in brackets, it turned out Tesla never actually made his death ray. Yeah. That's what we're told. So that would be quite interesting, wouldn't it?
Yeah, but you think that if they had a death ray, they probably would have sent it to Ukraine by now.
No, they wouldn't. It's not a big enough war to give away a weapon like that. That's a major...
Maybe they have got one and it's in on satellite somewhere.
Yeah, well, they could have. Yeah. But there you go. Yeah. So there you go, people. Find out the strangest things in this world, don't you? Donald J. Trump's uncle took Nikola Tesla's notes.
That's crazy. Yeah. Who would have thought that? I thought you were having me on there.
No. Hey, I very, very rarely have you on, mate. Very rarely.
True. But yeah, so that was the moon. I don't know if there's any questions or anything that's popped up in the chat that's worth covering.
Mark Andrew Chapman says 0 point energy might be a good subject for a show. 0 point's a bit of I think 0 point's a misnomer, because I think we kind of covered 0 point, didn't we, with quantum foam and all that? Then we found out that if you whatever you take, you have to pay back, and the longer you keep it, the more you have to pay back. Remember? Do you remember when we did that? Quantum foam. You know how you're supposed to be able to borrow energy from the quantum field, but if you do borrow that energy, you got to pay it back, and the longer you keep it, the more you got to pay back. So I think 0 point energy is a non-starter. Julie says she thought everyone knew that about John Trump. Well, there you
go. But that's also not to say that there isn't something else in the universe at work that we don't yet know about, that we don't understand, that may be used to create energy out of the vacuum.
Yeah.
The thing is that, okay, with our current level of understanding of physics and everything else, one set of things is possible. But who's to say that there's not going to be a breakthrough? Who's to say that Nikola Tesla didn't come up with something that they've hidden away because it was too dangerous or whatever, or they want to keep it for their own use? But maybe there's some aspect of physics that we've overlooked or that we don't understand yet, which makes something like over unity energy or 0 point energy possible. Who knows?
So Johnny John says induction really isn't that difficult to understand. Well, yeah, one can understand how induction is supposed to work, but how do you explain the electrical stuff behind it? That's the problem. How do you explain how a battery can be recharged without gaining any weight? So explain these things, then fine. But I'm still looking, and I think there's far better minds than your own that have tried.
Oh, there's plenty of those.
Yeah. See, this is the problem, because I mean, physics appears to be in disarray at the moment. It's just they're coming up with new theories about things, and 1 minute they're telling you the universe is 26 billion years old now, but they still can't work it out. Nobody knows anything. So the whole thing. I think there's a lot to be learned, or a lot to be discovered in physics. It's just the way science works at the moment. The problem is that unless there's something that can be quickly grasped and used and monetized, and people
and
aren't
also
interested,
that fits with the narrative. That's part of the problem with science, is that it's the same with things like Göbekli Tepe in archaeology. You would think that we've discovered this thing that's 12,000 years old, that they would have the whole thing uncovered by now and they'd be studying it. But they seem to want to just bury it.
No, they are. They are literally burying it and planting trees on top, which is going to destroy it. I mean, you might as well just go along the beach, dig a hole, and stick your head in it.
Yeah, and it's the same with the pyramids, but it's also the same in other fields of science where they're so locked into the current paradigm, or their funding depends on them attributing everything to climate change or to CO2 and human emissions and all that nonsense.
Yeah.
That if they deviate from that, or they come up with an alternative theory, then at the simplest level, they don't get the funding. And at the worst level, they get smeared and ridiculed, and you get treated like mainstream archaeologists have been treating Graham Hancock for certainly since Ancient Apocalypse came out. I think it's great that I haven't watched his second series yet, but I think it's brilliant he's done that, just because I love how much it winds up the archaeologists. And those guys, I'm sorry, they're dicks, because when you have something that, okay, so it shatters everything you thought you knew and all your assumptions, but surely you're not a scientist, you're not a proper scientist if you're not prepared to have your closely held assumptions like shattered to the wind when a piece of new evidence comes along. You don't just bury the bloody evidence and pretend it doesn't exist.
But do you not think people these days are so fragile? Because they don't want to hear anything that's against their personal belief system, or
they're not even prepared to debate it. I mean,
no, they're not.
You can't. You're basically wrong, and you're shut down, or you're censored, or you're thrown in prison in the extreme examples. And just, I mean, that's not how you discover new things. That's not how you broaden the depths of human knowledge. And you just end up with people like Michael Mann, who's one of the most egregious examples of the sort of scientist that I'm talking about that I can think of. Because then you just end up smearing. I mean, you just, if you smear anyone who disagrees with you as a denier,
that's a great word.
I mean,
see, that is, as soon as someone says denier, in my view, they're bringing a belief into what should be a fact-filled,
absolutely,
endeavor. So it's basically bringing religion into science, and I don't think it works.
I mean, it doesn't at all.
I'm not saying there is. I'm not saying there may not be supernatural forces. And when I say supernatural, I mean out with the natural that we accept as natural right now, because there are certain things that happen that you have no reasonable explanation for them. And there are a number of things that do happen that you have a reasonable explanation for. And whether people want to accept that reasonable explanation or not is entirely up to them. But as you said, on most occasions, what they do is, instead of engaging in some kind of argument, they basically just insult you and shut you down.
Yeah, absolutely. And I mean, it's childish apart from anything else. But it's also, when we're talking about serious things, like societal issues that are actually really important, that impact a whole bunch of people and impact everybody's quality of life, but also in some cases impact people in a physical way, when we're talking about men using women's private spaces and all this kind of thing. If we can't have sensible debate and it's just, no, you're wrong, so you're going to be shut down, or in the case of the whole Rona, you're dangerous, blooming anti-vaxxer, and it's just, you end up creating the society that we've got now. And and it just seems to be getting worse. It's the thing. I mean, just blows my mind. Absolutely blows my mind.
You're slipping into tomorrow night's discussion, probably.
Yeah, no, I know. That's for all in.
Yeah, so
but yeah, that was the moon, and I hope people enjoyed it.
I'll take this last one from Matthew Blackman, who says, like the giant skeletons hidden at the Smithsonian.
Amongst other things, I'd like to know what's in the Vatican archives, and I'd like to know what the Smithsonian's got squirreled away.
I found out the other day, if you get into the Vatican archives, right, and people do, right, if they have like a genuine academic reason and whatever, they will let you in. But you have to sign an NDA. Did you know that?
I didn't know that, but it doesn't surprise me.
So yeah, so once you're in there, what you find out isn't coming back out, unless you'll end up in fucking jail, no doubt.
But so how does that work with research?
Well,
because if you need to say, you need a piece of a text that is only in the Vatican archives,
right?
So surely you must be able to have a quotation from that book, or whatever.
Yeah, I would imagine that there will be parts of it that are verboten, right? That will be maybe adjacent or part of the stuff that you're looking at, and your mind will be fucking blown away, and then you'll realise, but I can only tell people about the stuff that actually came in to tell them about. I can't tell them about all this other stuff.
It's like, oh my god, they've got E.T.'s skeletal bloody thing hanging up.
Yeah, or they do have a Tesla death ray, or the chronovisor is real,
That would be freaky.
Yeah, wouldn't it? So, yeah. Well, I think we've come to the kind of the natural conclusion of tonight's episode.
Mm-hmm.
Oh, I need to change.
Yeah, it's been good. I hope people enjoyed it. I mean, I find them, and I mean, I think we'll probably come back to the moon, because it would be interesting to do a bit more on hollow moon theory. But
I'm still interested in following the journey to the moon, with Artemis and whatever, whether they're going to actually do it. Because do you remember those YouTubers and that got selected to fly round the moon?
Yeah.
Well, that was meant to have happened like 3 years ago. And we're still not there, right?
No.
So, and then, I saw something, I mean, Elon Musk's video stuff is fantastic, I must admit. I love ripping the piss out of it. But I saw a video the other day that was a simulation of two starships docking and transferring fluids. Now that's part of the tanking run that's going to have to happen in order to get the lander to the moon, because their intention is to bring down this huge lander, basically. You know, I can just see this going all fucking sorts of wrong. You know, because he's going to try and land one of his tall rockets on the moon in an upright position so that it can take off again, right?
Yeah, but he's only managed to do that. So yeah, I mean, they've got the barge thing, and he's caught the. I don't know.
But the
moon, watching that rocket being caught the other day. I mean, I've always been a fan of anything space related.
Oh, it was
given
cool.
Given the size of the bloody thing. I mean,
it was cool.
Yeah. So to say that
people,
he's not.
People were like saying it's fake, and I don't think that was.
No.
I think that was real.
And there's people that were actually there watching it.
But
and multiple different angles.
That's the thing.
And yeah, it could be fake, but
to go back to the moon thing though, the thing that gets me is it's going to need between 16 and 24 tanking launches just to fuel the ship up that's going to go to the moon and back.
Why don't they just use the same tech that we used the first time?
Because we lost it. We can't find it anymore, can we? You know, Saturn V is completely beyond us. Only had one engine, but it was a fucking good engine. Took us to the moon and back. Yeah. It's just it beggars belief, doesn't it? You know, they allegedly went to the moon in 3 days? And it's going to take us something like, that flight that they sent round the moon, why did it take so long? Why did it take remember they sent one unmanned one round? Why did it take 3 weeks? Where the hell did they go? Did they stop off at, Lunar Sainsbury's or something?
I don't know, maybe it was going a lot slower.
It's just no advantage to that.
I don't bloody know.
I mean, you're already doing 17,500 miles an hour when you get up there if you're in orbit, at least. It's just, the whole thing's mental. It
is.
I can't see us getting to the moon again. And Amy brought this up earlier, and the big question is the fucking radiation belts.
That's one of my big issues with did we go to the moon or not? Is and the classic argument is, well, there's ways to, if you go out at the poles, that you can escape without hitting the Van Allen belts too much.
But going out at the poles is a fucking logistical nightmare. It's one of the hardest launches you can do, isn't it?
Well, supposedly that's what they did. I mean,
no, they didn't. They didn't go out to the poles.
Did they?
No, they took off from Kennedy. Kennedy,
and they didn't remember that. But the point is that
I think what they said was, we went through the radiation belts. Didn't really notice.
Well, supposedly they went through thin parts, and I'm not sticking up for it because I'm in your camp on this, but that's the classic argument that one always gets when one raises it with someone in an attempt to have a serious conversation about it.
Well, the other
which one just doesn't work.
Yeah, the other bit that gets me is that guy from NASA that was on. Do you remember that interview? And he's going, he was giving it big on Artemis. It was like an advert for Artemis, and he's going, yeah, but we've still got to figure out how to get through the radiation belts. And I'm like, huh? What?
It's like, but you've already done this. We've been here. It's
allegedly.
I mean, but that's surely that grab, because it's, I mean, what other technology that we've ever had for the first time that was just lost, and we just thought, no, we're just going to chuck that away. We don't need that anymore. I mean, why would you do that unless you had something to hide?
Yeah, we wiped it. We recorded. We recorded, the days of our lives over the tapes.
Yeah, it's like, what the hell?
I mean, it's fucking just ridiculous, isn't it? It's ridiculous. Yeah, we were a bit short on videotape, so we just recorded over that one. Yeah, I don't think
Meanwhile, they still have the computers that they use on the Voyager missions, and they've managed to keep those Voyagers going. I mean, if you actually look at the number of different things they've had to do with those two craft.
Yeah. Right. So here we go again, because this is the one I can't get my head around. Is, you know what the inverse square law is, right? So power drops off with the square of distance. So by the time you've gone, like, 9 feet, your power is down by a factor of 2 or something.
Mm-hmm.
So, and that keeps going, right? That inverse square law doesn't hit a ceiling; it just keeps going. So, how are you still picking up signals from something that's billions of kilometers away?
With great difficulty.
Yeah, I would say so. Right. Anyway, the audience is starting to desert us.
I think it's time.
Yeah, thank you very much, people. And thank you very much, Ed, for that most illuminating conversation.
I'm glad you enjoyed it.
The megalithic yard thing was a bit mathematical.
Yeah, no, there was a bit of maths in there, but it's unavoidable.
Lots of 3s and 6s and 9s, and
4s.
Didn't Mr. Tesla? He didn't mention 4 so much, but he was really into 3s, 6s, and 9s, wasn't he?
Mm.
Yeah. Right, people, don't let that supermoon keep you up, and don't worry about the werewolves, because they only bite once. Next week, how about walking trees?
Walking trees? Tree ants? Yeah. Go on then. Let's
like
talk about. I didn't even know there were such a thing, but let's do that. Yeah, sounds good.
And everything. So yeah, let's have a look at them. So
excellent,
everyone. Thank you very much for attending this, and I'm not even going to bother with a player. I'm just going to say thank you. I love you all. Good night.